Hey everyone. Thanks for joining our StackRox office hours. My name is Andy Klemenko. I am now a principal specialist solutions architect at Red Hat, and I'll be moderating today's office hours. With me, we've got Robbie Cochran joining us today. He is a senior software engineer at Red Hat, formerly StackRox like myself. I just want to say before we start, I want to go over some ground rules of engagement, some ground rules, right? Lines are muted as the session is being recorded. On-demand recording will be emailed to everyone post-event. We will be answering questions live throughout the session. Make sure you ask your questions in the QA module in the, it says right-hand side, but left or right, doesn't matter. If you have any trouble with the webinar console, please refresh your browser. With that, welcome, Robbie. And what are we talking about today?
Thanks, Andy. We are talking about eBPF, the system in the Linux kernel that lets us run all sorts of cool stuff. And the goal today is to kind of go over an overview and to give people a handle about what eBPF is, how it can be used, and then answer any questions. And so from my perspective, I've been working with eBPF for a while. It's a massive, there's a huge surface area of use cases, technical details. And so I'm excited to hear questions from the audience and help people get a better handle. I think that would be the goal if you don't know anything about eBPF, to come away with a better handle on what exactly we're talking about here.
Cool. I just want to point out that eBPF is a mouthful. So for the sake of these office hours,
we could just drop
go ahead and call it candy corn.
Oh, okay.
I like candy corn. Let's come up with a fake name. Let's come up with a fun name, right? But yeah, we could definitely call it BPF. That's fine. Okay.
Well, from here on out, candy corn, BPF, interchangeable. If we get tired of saying BPF, I'll say candy corn. So to get started, I'm gonna share some slides here, and hopefully everyone can see that. So to begin with, we're going to talk about BPF, candy corn. We need to talk about what it is that's so sweet about this subsystem in the Linux kernel. And to do that, let's take a step back and remind ourselves, what is the Linux kernel and how is it different from processes running in the user space? So when you run an application in the cloud, usually you're running on a Linux VM, and the processes that are running in user space have to do different things, like write to the network, create a file, execute a program, and user space processes are able to do this by making system calls to the Linux kernel. And the Linux kernel runs at a higher privilege in ring 0 and has access to hardware, interrupts, things like that. So that's all great. And historically, Linux kernel is obviously open source. And if you wanted to extend the Linux kernel, you could just download the source code, write a patch, submit it to the kernel maintainers, and eventually your code may make it into the mainline kernel, and then you can use it in your infrastructure. A easier and alternative method to extend the Linux kernel is to write a kernel module. Now, kernel module is a way to essentially inject code into the Linux kernel and have a way to extend whatever feature you want within the kernel. You can pretty much do whatever you want with the kernel module. But in order to do that, you have to tie it directly to the version of the kernel, and the kernel is changing constantly. So kernel modules have their own overhead and issues. So what BPF allows us to do is essentially extend the Linux kernel without submitting patches, without writing a kernel module, and extend the Linux kernel with ways that it's more safe, and it's easier to do continuous delivery as the kernel changes. And ultimately opens up a whole world of applications, from security monitoring to debugging production issues to just building whole new networking stacks that are more extensible. So to begin, I'm going to start with a demo, and let me switch over to my command line here and show you. I want to show a tool that's linked in the background list on your panel there, called kubectl trace. So running BPF is, you can think of BPF as the low-level assembly language for extending the Linux kernel. And what it allows us to do is, let's see, it allows us to get whatever data we want out of the kernel by writing small scripts. These small scripts are then compiled into a bytecode and then run within the kernel. And so before we get into the technical details, I just want to give you a flavor of what we can do. So here I have a Kubernetes cluster that is not doing anything. I have a completely empty cluster. And what I'm going to do is use a tool called kubectl trace, which is very easy to install. And if you've never played around with BPF and want to give it a go, I think that kubectl trace is one of the easiest ways to get started. Let's see what we have here. We have 4 nodes in this Kubernetes cluster, and I'm going to take this first node and run an eBPF program that will print every process execution. So what's going to happen is we'll attach a small snippet of code that will be injected into the kernel, validated, and run in a safe sandbox manner within the kernel, and we'll send back to user space every process execution. So let's look at what this looks like. Kubectl trace. What do we want to do here? We want to run a program on this node, and we're going to let's see. Here we go. Got this set up. So I have a set of programs that are provided by the BPF trace utility. So you can think of BPF trace as a higher level abstraction on top of BPF. So if BPF is assembly code, you don't want to have to actually write BPF bytecode. We want to have a higher level of scripting language that makes this much easier to do. So this is pretty simple. I'm just going to attach a exec snoop function here that's created. And now what we can do is just tail the logs of this pod. Let me get the pod that was just created. So what kubectl trace did was launch a pod in the Kubernetes cluster with the appropriate capabilities and admin privileges. It used the BPF system call to run the exec snoop BPF trace program. And now when we tail this pod, we're going to see all of the process executions that are happening on this node. And like, yeah, I don't actually even know what we're going to find here. It looks like we've got some health checks that are happening via curl. This is kind of under the hood of Kubernetes. You can see with nothing running, what's actually being executed. The kubelet is talking to the container runtime, and we've also got a couple config map updates and things like that. So this is all being printed out right now by our little script that we attached to the cluster, a particular node in the cluster. We can also do things like attach. Actually, before I do that, let me show you what this BPF trace program looks like.
Hey, Robbie, real quick.
Sure.
We got a lot of questions about eBPF, the kubectl trace. How did you install it? Is there a quick, easy way to do it?
It's super easy. If you go to, it's essentially just a command. It's a kubectl plugin, and I think there's several ways. You can just put it in the right directory in your on your system, on your local system. You can also install it using Krew, Krew, which is a tool to extend kubectl. And then you can essentially just, like I said, I think this is the easiest way to get started with BPF especially if you're familiar with Kubernetes. So let's look at this real quick. Great questions. Let's see.
So I'm going to answer a whole bunch of questions at once. I'm going to go ahead and I'm going to answer one person and then have it pushed out to everybody for the answer of where we've got it, because that might help as well.
So if we look at what this script does, it's very simple. It's just attaching to the syscall execve, grabbing the arguments that were passed to execve, and this is going to be sent via the eBPF subsystem in the kernel to a buffer, and then the user space program that created and attached this can read the output. So essentially it's going to stream out exactly the data that's being attached here. Now you can imagine that these programs can get really complicated. You can do a lot of sophisticated stuff. I'll show you just one other example for this demo. Let's attach a TCP connect script. And then tail that, and we should see all of the connections that are occurring. Let's see.
Yeah, while you're doing that, one of the interesting questions was around some of the use cases, and really, and there was another question that was kind of along the same lines. Really, to kind of think about eBPF is this is the underlying technology that allows observability into the kernel space, right? So it's not a kernel module, which is slightly different in the way in functional, but in terms of use cases, you're going to be interacting with monitoring or security applications. So very few of you, I would expect, would ever be able to go to this level like Robbie. In fact, even I don't go to this level.
This is, I think what I'm kind of showing now is a great tool that's useful for debugging production issues. Essentially, if you have you know that the file system, file activity is using too much CPU. It's like, well, where exactly is the time being spent? Essentially, you can think about this as a JavaScript or a debugger that allows you to attach to different events and then extract that. And you don't have to change anything about the kernel. So just now that we've kind of like given you a taste of what we're able to do, let me take a step back and switch over to here we go. And I'll go back to the slides.
So real quick, there's a question about your eBPF pod. Does that need to be cleaned up like a job or any other pod within Kube?
Yeah, it does. So what the pod does is essentially it runs on the node that you attached it to, and it runs as long as you're using the BPF trace script. So if the script needs to get what I was showing now were streaming scripts where we were actually printing out the events as they occur. You could also have a BPF program that aggregates data. We look at create a histogram of latency for connections, or histogram for how much time is spent within a particular region of the kernel. And so it really depends on the use case, how long you want to leave your kubectl trace pod up. So now that I've given a semi, in my mind, high level, but like, this is I'm feeling like maybe I need to even take a step further back without going into, so I'm going to skip over a little bit of this here. I think one thing I want to get across is this idea of the virtual machine within the kernel, which is what BPF is, has been around for a long time. If you've ever used TCP dump, that actually is a command that will compile your query into a bytecode that's run within the kernel. And this has been around since the 90s. But more recently, eBPF has been created, and it's a redesigned VIA model where the BPF system call allows for you to inject these programs within the kernel. The workflow is essentially you write an eBPF program or use a tool that has written the programs for you, like kubectl trace. There, I wasn't actually even writing eBPF. I was writing BPF trace, which is a scripting language. As I said, the pros are that no kernel modules required. You can construct much more sophisticated analysis with the kernel. The only drawback is no support on very old kernels, but there are a lot of backports. And I would say if you have seen eBPF, mentioned a lot and like why exactly it's particularly useful, I think like a lot of the same of course, the Linux kernel has been around for a while. A lot of the same development practices like have enabled much faster evolution of kernel features. And so eBPF has evolved really quickly and kind of even more emphasizes the trade-offs of a kernel module where you have to keep up with all the changes within the kernel. eBPF, you can write a program that should work as the kernel is updated. eBPF also provides a lot of features like a verifier that runs when you insert the code. That means that your eBPF code is safe. So your candy corn isn't poisoned. It's not going to crash. It restricts the things that you can actually do. So it actually imposes limitations, which enable additional safety checks. And also allows for, by making sure that you're not going to, step on your own toes and do something that's going to cause a crash. Because usually when the kernel crashes, that's going to cause your system to reboot. So how do you write an eBPF program? So I showed you one way to do that using BPF trace. Ultimately, at the low level, it's the BPF system call. And you can do this by either writing eBPF assembly by hand. I don't think most people are going to do that, though. But for performance tuning and things like that, you may want to do that. Or you write in C and use a suite of helper libraries to help you insert these programs. This is what the system call looks like if you want the nitty-gritty details here. Essentially, it's, you have a one-size-fits-all where you have different types of commands that can be run via the system call. And this gives you a little bit of a flavor of the different types of programs that can be run with BPF. This isn't just like network or process executions. You can attach to really anywhere in the kernel that you're interested in. And if you've heard of trace points or kprobes, these are attachment points within the kernel. And trace points, the big takeaway here is that trace points are more stable. Trace points are stable as over kernel versions, but a kprobe may change over time. Here's an example of a really simple eBPF program that gathers the last PID that called a particular system call. But really, you're not going to want to write such low-level stuff. You're going to want to use a compiler collection like BCC or BPF trace. And BPF trace is most useful for debugging and profiling. But there's also security utilities, networking, and monitoring that's built on top of BPF that includes the whole platform and user space as well. So you're not actually triggering and running the BPF program. You just run, for example, Falco, which you can use eBPF, or Cilium, which is a networking stack. And so that was kind of a whirlwind tour of some lower level BPF features. And here I've posted some resources that would, I think, be a great starting point for doing BPF development, additional guides and documentation that are very useful, and then a list of the tools and platforms that are using eBPF. Falco uses eBPF for security. Their Aqua Security has a tool called Tracy. StackRox, we use eBPF. And as part of our acquisition, we're in the process of open sourcing part of our tools. Stay tuned for... That's right. stay tuned for announcements at KubeCon EU. There's a whole world of really cool stuff that's happening at Cilium to extend the networking stack. OS query, debugging, as I showed and demoed with kubectl trace, and then some really bleeding edge access control functionality that's been added to the kernel recently called the kernel runtime security instruction. So with that, I'm going to stop here. Yeah,
I got a question for you, Robbie. So if I'm an executive and I'm reading CTO Weekly, what is the like 10-second elevator pitch for eBPF? What is it doing for me?
I would say, well, I'll try an analogy and see where we go from there. So imagine your browser without JavaScript. If you just had plain HTML, there was no dynamic programming. If you wanted to, add a new feature, I don't know, does anyone remember the blink tag in HTML? That's the kind of thing that is really slow moving. But JavaScript, opened up all these opportunities for new platforms and new things that you could build on top of the browser. And because the majority of Kubernetes clusters and cloud native tools run on Linux, Linux is kind of the lingua franca, the one kind of like lowest common denominator for all of these tools. And so if you have a way to extend the Linux kernel, well, that means that you can, support anything that's running on Linux, whether it's debugging, monitoring, security, or networking. And the other kind of key takeaway is that moving from user space to kernel space is expensive. And so if you can put some logic into the kernel, that is a performance win.
That's cool. Because actually that dovetails really nicely. There's a question about performance implications of eBPF, specifically Kate CNI versus IP tables. As far as I know, IP tables performance scales at 0 to the n with number of VEF devices, while eBPF scales to 0 to 1, 0 to the power of 1, I'm assuming is what it says. Mm-hmm. So performance, what does eBPF give us on performance?
So for example, so IP tables is doing some of that routing in user space. So you create, a round trip from user space to kernel and back in order to validate whether a packet should be dropped or, whether we should allow a particular connection to be established. And by putting the logic and the filtering and things like, of course, some of this already existed, but eBPF allows the Linux kernel to extend that. So from that perspective, it's a performance win because it's closer to the, right when the packet arrives. There's a subsystem called XDP, Express Data Path, and that is where a lot of the eBPF extensible happens. From the other angle, you might think like, oh, VM, that's going to be slow to execute. The bytecode that is injected into the kernel is actually compiled to machine code after it passes all the validation checks within the kernel. And so the logic that you write is running at the machine level.
Cool. Okay, I apologize. I'm trying to figure out how to share in this platform or better yet, if you know how to share, I just spun up a StackRox cluster, actually kind of highlight how eBPF maybe integrates with a solution, a monitoring solution, or a security solution. Give me 30 seconds. I'm like a kid without a, oh, there we go. There's a screen share button. Look at me figuring this stuff out. Okay, give me one sec. Awesome. There we go. Okay, does everyone see? Yep, looks like we see it. Awesome. Yep. So just to kind of give you a highlight, right? So I literally just spun up in a matter of like 6 minutes the latest version of StackRox. But what I kind of wanted to highlight was the fact that I have 3 nodes. And I can actually go into the platform configuration and look at the clusters themselves. And I'm going to drill in. And we can actually see, to prove to you, I am using an eBPF program for collection. Now, the one interesting thing about our platform is that we can use kernel modules or eBPF. It depends on your comfort level and depends on your access permissions and access to the nodes themselves. But eBPF is really kind of the new hotness, right? But just to kind of show you, just kind of highlight what some of the things it can do is we can look at, like, say, network graph for a second. So we can understand, in fact, here, let me go ahead and deploy a bunch of fun stuff to this, and we'll see things pop up, actually. We can actually watch the violations. This also is a good window because this is showing, as applications come up, we're able to assess not only processes that are running from a runtime standpoint of view. There was one right for network management execution, right? So eBPF is giving us the Kubernetes native, kernel observability, for lack of a better term, because we've written those eBPF programs that Robbie was talking about. And it wouldn't be possible without an eBPF module or a kernel module to get this level of observability, right? There's some tools out there that write their own agents, but effectively it's doing the same thing because the kernel is the heart of every host OS, for lack of a better term. So hopefully this kind of helps in terms of some of the use cases, and then we can go back to the network graph. There we go. We can see that I've spun up a whole bunch of namespaces. I've got a bunch of fun applications here. Keycloak, Graylog, things like that. Cool. Now that I know how to screen share, I want to keep going. Okay, let me stop and let me look at all the questions real quick. So we've got some really good questions, right? There is one about eBPF storage. That would actually be really interesting in terms of being able to manipulate the kernel space, right? Is there a chance for eBPF pods to get compromised? What do you think, Robbie? Can a hacker exploit that?
So there is a lot of work that has been done to harden the eBPF subsystem. You're not allowed to write certain types of programs. You can't have loops, actually. And what the reason for that is by limiting what you're able to do, verifier that's within the kernel can actually check all possible paths within the program. That's one thing that can do. And then additionally, you're limited. You can't, first, the regions of the kernel that run eBPF are read-only, and you're limited to what you can access. You have to use a set of helper functions to access different parts of the kernel. You can't read kernel memory directly from within your eBPF program. There's additionally Spectre mitigations for eBPF, and from the perspective of an eBPF program versus a kernel module, eBPF is much more secure.
I was going to ask that, right? It's really about, I think those helpers in the limited scope reduces the surface area, right? Using the security buzzwords, right?
Absolutely, yeah.
Cool.
It's a sandbox. You could kind of think, frame it however you want. It's using a lot of the state-of-the-art containment mechanisms.
Yeah, and Linus Torvalds put it into the kernel himself, so it's got to be good, right?
Yeah, totally.
What are the cons? What are the cons to eBPF? That's a good question.
That's a great question. I would say some of the cons are that it depends on what your use case is. If you're writing a custom kernel module, I think it's there aren't that many trade-offs. Really, it's just better to use eBPF. Now, there are other ways to get data from the kernel. If you want to go real old school, you just read the proc file system, right? You just look in there and see what processes are running. Maybe eBPF is too much. You don't need all the features of it. And so that's a con. Another one is that usually you need to make sure you're running the latest kernels. Now, if you're on the cloud versus on-prem, cloud kernels are getting updated automatically, and you're going to be on top of that. But if you're on-prem and maybe your kernel doesn't get updated as often, maybe there's features you want, and so you're better off using a kernel module that's going to give you what you need.
Yeah, this is my own question. I got another in the Q&A, but this is my own question. How dependent are those eBPF programs to the kernel module?
So what do you mean by dependent?
Well, okay, so a kernel module needs to be compiled to that specific kernel with Linux headers, right? Kernel headers.
That's right.
Yeah, on an eBPF point of view, is it similar? You got to compile it, or is it a little more dynamic? In other words, as you move up, as you run yum update and update your system, you're not going to be like, oh, I'm going to get the latest version of eBPF or whatever program.
Well, so the kernel can certainly make breaking changes, but there are certain guarantees you have. And it depends on what memory and what kind of structures within your program you're accessing. I mentioned trace points and k-probes. These are just examples of events or hooks you can attach to, and they have varying levels of stability. K-probes could change at any minute. Trace points are much more stable. And so that's one angle, like what data are you getting? And then this notion of building yes, you're absolutely right. To build a kernel module, you need the kernel headers, and those change. You need to, essentially build a kernel module for each version of the kernel. And there are, thousands and thousands of kernel versions that are, appearing with patches and constantly. So you need to recompile every time. That's a big, you do need the headers to write an eBPF program. Actually, the kubectl trace tool that I demoed mounted in the pod the headers on the node, and then used those headers to build the probe.
So it cheated.
It cheated a little bit. Thankfully, there's some people working on things that allow you to just get that data directly from the kernel itself. It's called compile once, run everywhere, which is a core. And so that is kind of the future and the next step, where you can have a eBPF program that'll run on any version. Yeah.
So really abstract away the kernel version. Got it. So we got to stop. I got to be a little selfish here. There's a question about StackRox. Sorry, I got to take this one. It says, does StackRox integrate with other open source cloud native security products, i.e. Falco, OPA? Yes. Let's put it this way. I'm trying to think of a good way. Imagine, to use your browser analogy, right? Think of StackRox being your, I don't know if you remember back in the day where you take multiple modems and you pull them together and to create a big pool, and that way you'd have much more bandwidth. Think of StackRox as kind of like that next layer of abstraction from a tool like Falco, right? Where Falco is using the same ePF for kernel module and doing the same kernel instrumentation observation, right? What we're doing is we're taking it up a level of abstraction where we're able to start tying together Kubernetes native constructs. As I tell my customers, we can traverse the Kubernetes logical separation tree very nicely, right? Between deployments, between namespaces, and start to bring up that observability from a low level all the way up. And so that's one of the big differences. Can I say it, Robbie? I got to say it. So part of the announcement at KubeCon is that we will be actively contributing as Red Hat to the Falco open source project. Can't go any further than that, but because I don't want to ruin the surprise. But yeah, the StackRox as a platform is an abstraction layer above, and we like Falco.
Yep, totally.
Okay. Cool. What are your thoughts on OPA, Robbie? I'm kind of curious on this one because he did ask OPA.
So OPA is an awesome platform for gluing together and building policy. As far as the integration points, there's a lot of ways that I think StackRox has the potential to work with OPA. One issue with OPA is that, if we're kind of taking a step back, OPA,
Rego,
gatekeeper, Rego, yeah.
Rego. Like we had trouble with YAML, not to mention TOML. Rego? Regex?
Yeah. Yeah. And so, I mean, the ability to kind of put together policies and run them in a much simpler way is something we worked hard on in the product.
Nice.
And that's that's what's really exciting about the Red Hat acquisition is we're starting to think about pieces of the product that we can pull out and maybe integrate with other things and maybe make Rego easier to use.
Yeah, it's called YAML. Sorry, I had to do it. Or TOML. That was my favorite one, was TOML. Okay, another great question. I love these questions. Keep them up, team. Is it possible to integrate using OpenAPI, StackRox, with other Kubernetes as a service SaaS platforms? If you're talking like XKS, EKS, AKS, DigitalOcean has one. The nice thing about our platform is as long as it's Kubernetes, right, big air quotes there, as long as it's a Kubernetes SaaS, yes, we should be able to. There are some caveats in terms of having privileged access to the nodes to be able to run eBPF or run the kernel module. But for, well, honestly, most use cases, you should be good to go. Definitely test it out, and we can definitely help you with that. If there's a specific platform you're curious about, just throw it in the questions and answer, and I'll let you know. Basic thumbs up, thumbs down. But from all the ones that I've seen in terms of customers using, not an issue.
That's
cool.
I'll just add there, Andy. Made me think of a good reason that eBPF is used is some cloud providers just don't allow kernel modules, but they will allow eBPF. Yeah.
I think that's smart from we talked about the surface area. That's incredibly smart to kind of limit the blast radius. I always love that term. OPA or Kubernetes? I'm going to put my opinion out. I hope it's okay. I think OPA, because of Rego and Kubernetes, there's a certain level of like, it's like, no offense, Robbie, the eBPF programs themselves, right? Where there's a huge barrier to entry. And once you're in, yeah, you can rewrite the world and move the world, and it's great. But because it's such a huge barrier to entry, I think until there's a tool that comes along that abstracts away, think about like trying Docker Swarm. I used to work at Docker, so I'll pick on them. The first version of Docker Swarm was horrible. You had to install like 15 different things, and it just didn't work. It got better. It got better. It got better. And I think until the policy, the OPA stuff gets better and easier to implement and use, you're going to see it as, an extreme edge case where, like the SaaS model, unless it's built in, people ain't going to use it because it's just, there's enough of a learning curve that we should abstract away all these things. That's just my opinion. I hope. What's your opinion on OPA and Kubernetes as like as types of instrumenting?
Like these, all of these tools are very powerful, but they have to be maintained, and you want to be able to allow your developers to, develop quickly and also have some guardrails. But if you're constantly going in and tweaking the rule sets or the policies and you don't have an easy way to update them, then that's going to slow you down. Now, OPA and Kernel, they're all very powerful, but it all comes down to ease of use, I think.
Okay, cool. So Chando is gonna rephrase that question, but there was one about Orca and some of our competitors. I know. We'll give you a little backstory on StackRox. About 2+ years ago, actually about 4 years ago. We were kind of like a typical agent install with some of the other tooling that's out there, and decided to pivot and go Kubernetes native. And what that really means is we need Kubernetes to deploy. We have deployments, daemon sets, all of the Kubernetes object landscape that is just sometimes frustrating. But it also means that we hook directly into the Kube API. We've got service accounts that can do that with RBAC. And so we're using Kubernetes built-in structure to talk to it, as well as the eBPF to pull that information out and draw it together. And it gives us a really interesting opportunity, like I said, to navigate the Kubernetes logical separation landscape and make some really interesting connections in terms of data. One of my favorites is a violation happened because something happened in a running container. Well, within 2 clicks, I can see the Docker file that the image was built with. I can look at the CVs, and being able to pull those data points together means that if you're in a dev environment, you'll be able to troubleshoot the issue much quicker, or if you're in production, you can isolate the problem and even turn on policy enforcement to kind of affect that at an insane velocity that I think trying to connect it with different tools out there gets very tough.
Yeah.
That's just
To like kind of extend that, the demo where I showed all the processes that were executing, all we had there, that was on the node. All we had was the process executions. We didn't know which container, which deployment, what image was running that process. And if you tie all of that stuff together, then the stuff that's an anomaly or something malicious really stands out. It was either something running on the node that shouldn't be there, or it's like, why is this database spawning a shell? That you need the context to be able to like make security decisions.
Yeah. So Chando followed up on his question, his or hers, I apologize, their question. Is it possible to integrate StackRox using StackRox's open API with K8s as a service products like Platform 9 or GitLab or Shippa? So there's or Argo. Argo is one of the fun ones, or Weaveworks. There's a lot of landscape there. Yes, being Kubernetes native, we can integrate with all of those tools. I've personally written Argo pipelines. I figured, Helm effectively, Argo can translate Helm with Customize and all that. We can definitely deploy StackRox as a service, AKA, like Argo CD kind of methodology. We also have Helm. My favorite personal install is the whole KISS principle, where we can install as just Kubernetes YAMLs. It gives a lot of control over how it's deployed. I think having the choice, though, of at least say Helm, and then, we're Red Hat now, right? So we got to have an operator. So between those three install paradigms gives a lot of control over how you install, where you install, and what you install from our platform. It's a good time to be alive, let's face it, in the StackRox world. Here's another good one. What significant differences between Sysdig Enterprise version of container security by Enterprise Falco and StackRox? First off, I don't like talking negative. It's a waste of time. I think in terms of talking positive, right, I can tell you our benefits. I think it's that Kubernetes approach, the Kubernetes approach, right? We're looking at everything. And one of the things that I think we do, maybe even to a disservice, but Sysdig will grab everything. We don't, right? And I think what's interesting is understanding, quote unquote, our swim lane, right? We're looking at the pods and the containers, the deployments and the namespaces, and those relationships. We're not looking at every syscall specifically. We're not saving every tiny scrap of data. Like our network layer, our network monitoring is metadata, not data. And I think we're not biting off too much from what we want to look at. And I think we're still able to provide the same kind of connections and relationships between the image, between what's running, what shouldn't be running, what has been run, and also prevention. If you want, I could probably find a logo wall. I could throw a logo slide and show that we're actively deployed in a lot of different and very interesting places that I can't tell you about. That's always fun. Hey, Robbie, have you helped out with any of the customer installs?
Yeah, I have. And I would say StackRox is really easy to deploy. It's up and running really quickly because it's all integrated with Helm and Kubernetes native. It just kind of works. You lay it out over all your clusters, and there you go. You're immediately seeing kind of insightful data.
Yeah. This is a good one from Waleed. It says, do you advise Cilium as a CNI for OpenShift, ? Or how do you do network segmentation and network policies? I'm going to give you the real simple answer. We don't care what CNI you use. We're working at the Kubernetes level. In other words, we deal with network policy objects. And here, I got to do the demo because it's just a fun little demo. Let me flip over screens. Make sure I get the right browser. I can't figure out which one it is. Oh, there we go, network graph. Okay, cool. So here's my network graph, and I can zoom in. But what's kind of interesting, let me pick on a namespace. Let's pick on Keycloak. I haven't picked on that one in a while. Okay, so we're looking at the metadata of all the network connections. And what we can do is actually really interesting because of the behavior analysis engine we've got built in and the network metadata is we can go and scope in by namespace, we can scope in by time, but we can do a network policy simulator. And what this is going to allow us to do, and here's a great example, this is going to allow us to create a Kubernetes native network policy object. This is independent of the CNI. Actually, this is 1/4 layer, half layer up from the CNI. So we don't care what CNI is doing behind the scenes. This is saying, hey, Kubernetes, don't let those two talk. And what this also means is we're underneath the service mesh. So if you want to run Linkerd, if you want to run Istio, if you want to run Mesh or whatever the latest and greatest is this week, because everyone has to have one right now. It's a fun time to be alive. This gives us the opportunity to work kind of in between those two layers. So any CNI, any cloud provider, because I know some of them use different things, any service mesh. And here's the fun part. This is what I love, is downloading the YAML. Because now you can actually save that with your application, whether it's Helm, Kubernetes, how you deploy it. And that way, when you go to deploy it in production or you go to deploy it in another place, you've already got the network surface area kind of locked down. So that's kind of fun.
Yeah. And that like tightened, improved network policy just generated with StackRox, created by observing during runtime network connections that were observed via eBPF, if you have that feature enabled. And yeah, if you're whatever CNI you're using, it's ultimately still going to interact at a level where we'll be able to observe it and see those connections.
Yeah, there's a good question in from Sudeep. It says, how does StackRox compare with public cloud security offerings like Azure Security Center, please? One major way, you can't run Azure Security Center on Google or AWS, right? Honestly, I don't know that tool. Maybe you know, Robbie, but
I don't. I'm not familiar with it. Yeah.
Yeah, I'm not either. But what's kind of interesting is this idea of cloud agnosticism, agnostic. And really it's around deploy anywhere, right? Any Kubernetes, or this question actually came up in with one of my customer meetings, any CNCF-based Kubernetes. So I've actually successfully installed StackRox. I mean, my demo uses K3S. I don't know what you were running, Robbie, in your cluster, but I've seen it on, not Nomad, but Convoy from D2IQ. I've seen it on many different versions of OpenShift and Rancher and AKS, EKS, DigitalOcean's, like Civo has a managed hosting. I've just seen it work on everyone because it's Kubernetes. So that's kind of an interesting differentiator from the public security stuff. Cool. Another question. It would be more interesting if the net pool can have specifics for Calico, Cilium, where it has more host mesh. Okay, I think where you're going with this, right? So you want to drill from the Kubernetes object down into the CNI object, and you know, I actually had a conversation with a government entity earlier about knowing our swim lane, right? And I always joke about the 7-layer burrito, right? Where Robbie was down underneath the tortilla and some of the eBPF stuff. But if you think about the host, and then, you know, the host with its operating system, and then the Kubernetes, and that's got obviously CNI and all that, like where we are in our swim lane, I think is really interesting. And there's so much information full stack that you'd lose it, unfortunately, I think. Oh, I'm still screen sharing. Look at me. Yeah, I think you'd lose a lot of value just getting dumped with all that information. And I think so for us, concentrating on our swim lane is actually better, because then we can make our product better within those kind of guardrails. I mean, do you feel the same, Robbie?
Yeah, I do. I mean, you know, I think that people have mentioned Cilium, and that some of those lower level features are better. It's better for Cilium to manage that. And then we have a one size fits all kind of network policy that will work on Cilium or any other CNI. So yeah.
Cool. We're running out of questions. Where can we take the product with eBPF next, Robbie? I'm going to put you on the spot.
Well, I think that the question about, ingesting more information into the network policies is somewhere we want to go. Service meshes are opening up a lot of new again, that's kind of extensibility of the network where you're putting application logic into the network. And eBPF will let us do that. I would say another area that's really exciting and maybe a little further off is enforcement via eBPF. Let's just go ahead and say that we're going to have a rule set that's embedded in the kernel that doesn't allow certain program launches, or you just block the system call at a particular level. And it's blocked based on the fact it's determining what image is running, or, kind of putting some of these higher, that's what eBPF lets you do, these higher level primitives into the kernel, and, basically you can do whatever you want.
So is it fair to say you want to take the admission controller / policy engine enforcement out of Kube and move it down several layers?
I think that you may want to do that for invariants that you never want to allow in your environment. If you want to say, and I think that's where you can lock things down. Admission controller is better place, in user space for blocking. Yeah, exactly.
Yeah.
Exactly.
Well, cool. Fantastic. We do have some limited swag. I apologize that we weren't as forthcoming. I know some people were asking for stickers and stuff. I think here's an easy one. If you can put your email address in the Q&A, we might be able to arrange a limited number of stickers and stuff to go out. Unfortunately, we're waiting for obviously KubeCon, both EU and US, to kind of come back alive. So big hopes for that. So another good question. Oh, some more questions. Great. Do you have a plan to have Katakata Coda based demo environment for deep dive on all the StackRox features? From the sales point of view, no, because it's relatively easy to install on your cluster. So there really isn't, I don't think there's this need, because I think a lot of it would be tire kickers and just let's install it on your environment, so you can throw your applications at it. Actually, there's Play with Kubernetes, play-with-kates.com. I think there was, Marco did one for Docker years ago, and you should be able to spin, I don't think you'll be able to spin kernel modules up and eBPF up there, but it's relatively easy to spin up a single node cluster with K3s on a VM on your cloud provider or du jour. If you're interested, go to StackRox.com, and I believe there's a requested demo and stuff, and we definitely help you out there. With StackRox merging with Red Hat, I like that term, merging. Will it continue as Kubernetes platform agnostic, or will it be integrated more with OpenShift? Watch our announcements at KubeCon EU. But if I have anything to do with it, we will. The product known as StackRox today will continue to be cloud Kubernetes agnostic. Let's just say my customers require that, and my customers are very nice and very powerful, so we like them. We definitely like them. Awesome. Thanks for the kudos, Sudeep. Waleed says, so usually Red Hat open sources every project they acquire, having both open source project and enterprise offering. We know that Red Hat has already productionized StackRox as an advanced cluster security. What is the open source project? I've hinted at this, and I'm going to leave it a surprise. This is a teaser, so you got to follow our announcements at KubeCon EU. I'm not giving it away to you. Good try, Waleed. Well, that's a long. Okay, so does StackRox do partner programming of a SaaS product? Yeah, we do. We have. We do not do white labeling, so I like you call that out, not white labeling. Follow traditional, Red Hat's traditional like partnering programs. If you're interested, go to help.stackrox.com and not help, sorry, regular StackRox.com. I'm so used to saying help, but go to the website and fill out a request. And if there's a valid use case, we'll absolutely help you out. I mean, I think the more people that have this kind of visibility in their Kubernetes environments means like if Tesla had this, they wouldn't have gotten, their dashboard wide open, and there's a whole other, whole other hacks out there around Kubernetes. Cool. And we'll lead both Marcos, play with Docker and play with Kubernetes, I guess, from Marcos. Cool. Well, if we don't have any great questions coming up or any more questions, like I said, let us know. I see a couple emails in the Q&A, which is perfect. Any final thoughts, Robbie? What do you think? What do you think?
Oh, well, I mean, I'm just super excited to share some nerdy eBPF details, and glad and thankful for everyone that joined us today.
Cool. I am extremely glad you didn't stay in the weeds, because you were way below my level of knowledge. But great talking about candy corn.
Exactly. Yeah, I just want to give people a flavor. That way they've seen it. Now they know they don't need to go there. It's like they don't have to spin it up themselves.
Yeah. Well, what's also kind of cool is being able to understand where it is in that burrito, right? I hate to use that analogy. And then also understand what's on top and what's below and where things lie, because I think the more we know about burritos, the tastier they are, right? Let's be honest.
That makes total sense. It really does.
Can't argue with that. In fact, I think I need to go get Chipotle tonight. And for those that don't have it in your country, I'm sorry. It's kind of good sometimes. Or if you're on the West, I think, Robbie, you're on the West Coast, you can get the real thing. Out here on the East, it's, hit or miss. Cool. I'd like to thank everybody for joining. I think it's been a blast. Hopefully we've entertained at least for a little while and answered some eBPF and inadvertently StackRox questions, which I absolutely love, because I think it's a great product. I'm not going anywhere. If you have any additional questions, you can obviously reach out to the team at StackRox by going to the website. And I think, did we have on our main, we didn't have email addresses, but I'll give mine out there because I'm okay with that. It's clemenko@redhat.com. Yeah, feel free to reach out to me. I answer all the questions. Robbie, I'm sure you don't want to give out your socials or your...
No, if anyone has any eBPF related questions, I'm happy to answer. R. Cochran at Red Hat.
Oh, nice. Good job. Well, it's been a pleasure, team. I guess we can end the stream.